Welcome to this video in which we introduce Norton's theorem. Norton's theorem is essentially, conceptually at least, the same thing as Thevenin's theorem in the sense that we have a circuit which consists of independent sources, one or more, and other stuff, where the other stuff would be resistors and dependent sources. And the idea is that this whole blob of stuff, all of this stuff in here, is equivalent to a single current source in parallel with a resistor. Now this is very similar to the Thevenin equivalent, where all of this stuff over here was equivalent to a voltage source in series with a resistor. And in fact, you'll notice that we use the same terminology for the current source and the equivalent resistance as we did in the Thevenin equivalent circuits. And in fact, you'll notice that we even call the equivalent resistance R Thevenin, because it's the same as the Thevenin equivalent resistance. So if you're in a position where you need to find a Norton equivalent source rather than a Thevenin equivalent source, a Thevenin equivalent circuit, the process is essentially the same. You find the short circuit current, which again you get by shorting the two terminals. You find the open circuit voltage, which you get by leaving the two terminals open. And then you find the Thevenin equivalent resistance as VOC over ISC. And again, I'm not going to spend a lot of time on how one finds this and this. That's covered fairly completely in the Thevenin equivalent circuit videos that I've already made. One thing, though, that is useful to note is that there is a relationship between the Norton equivalent circuit and the Thevenin equivalent circuit. So if I draw the Thevenin equivalent circuit, it looks like this. These two are equal, and this voltage is the open circuit voltage, but I can also write it as RTH, the Thevenin equivalent resistance, times the short circuit current. This is actually true in general. If I have a circuit that looks like this, so it's a current source in parallel with with a resistance, I can transform it to a voltage source in series with that resistance, and vice versa. If I have the voltage source in series with the resistance, I can transform it to the current source. So that's a useful thing to know. Again, the process of finding a Norton equivalent circuit is exactly the same as finding the Thevenin equivalent circuit, except that at the end you draw something that looks like this rather than something that looks like this. So with that, actually, I think we'll end this video, and then there will be one example of computing, at least one example of computing a Norton equivalent circuit. So hopefully you found this useful. Thanks for watching.